So now we've come to our last example. What I'd like you to do is to pause the video, go ahead and read through the problem on the examples I've given you on Classroom. See if you can do A, B, and C, and then we'll go back through this together and see if you got it right or not. So again, read through this, underline any pertinent information, see if you can do parts A, B, and C, and then start the video back up and we'll see how you did. So as you've read through this, there's a couple things that you'll notice. First of all, right here they give you all of the population parameters for males and females. The average weight of a male or female, standard deviation, and then we do see that both distributions happen to be normal, which means our sample size does not have to be any greater than or equal to 30 for us to be able to do this. We also look right here, we have a particular sample of where 16 males weighed a total of 2,500 pounds. I'm going to put a red there because that's a red flag. They did give you the mean weight of that sample to be 156.25 pounds. So right there, since that is the mean from a sample, that is our sample mean. So if we look at part A, it says find the probability that one randomly selected adult has a greater weight than 156.25 pounds. So if we randomly select one male from the population, by the way, we're going to be looking at males strictly here, so we are not going to have to worry about the female parameters here. But what's the probability that one male would weigh greater than 156.25 pounds? Well, we got to look at our three different parts of the central limit theorem again. We got to look at shape, center, and spread for one individual. Again, this is a sample size of 1. Well, shape, it says that the distribution is normally distributed for male weights. So this is normal. Why again? Because it was given to us as normal. Because the population is normal. It told us that. Our center would be the same as the population mean for male weights, which would be 182.9 pounds. And since again, this is not a sampling distribution, it is we're looking at a single individual from the population of males. So we'll use also the population standard deviation of 40.8 pounds. So what you're going to do is those are what you're going to put into your stat app. Now, I'm not going to, we've done enough on the stat app, me showing you, you should be able to find this. If not, you should be able to do this on your stat app. But if you can't, make sure you can text me or give me a call or so forth. But the probability, if we use those, that a single male has a weight greater than 156.25 pounds should be equal to 0.7432. So if you're looking at individual males, about 75% of males have a weight greater than 156.25 pounds. Now let's go to the next one, part B. Everything's going to be the same. We're not looking at females, but this time we're going to look at and say, find the probability that a sample of 16 randomly selected adult males has a mean weight greater than 156.25 pounds, so that the total weight exceeds the maximum capacity of 2,500 pounds. So in essence, what we're saying here, ladies and gentlemen, is we're now looking at a sampling distribution where the sample size is 16. So how does this mean weight here of 156.25 pounds for a sample of 16 compare to other samples of 16 from the male from the population, the sampling distribution population of samples of size 16? So we look at the shape here. It's going to be normal. Even though our sample size is less than 30, it did say again that the population distribution was normal. So again, it's normal because the population distribution is normal. Now, since we're looking at a sampling distribution of size 16, we're looking at the mean of the sample means. Well, that's equal to the mean of the population, which again was 182.9 pounds. That never changes. Now the spread does. The standard error is equal to the standard deviation of the population divided by the square root of the sample size. Well, again, this was 40.8 divided by the square root of 16, which gives us a value of 10.2 pounds. So again, these are the two values we're going to use in our stat app. So, if we do that, we want to find the probability that the mean of a sample of 16 is greater than 156.25 pounds. And if you go to your stat app, that ends up being 0.9955. So it's very likely that if you have a sample of size 16, that the average weight of the men in there would be greater than 156.25 pounds.